Welcome back, guys. So today we'll be taking another problem based upon the binary search tree. The problem name is trim a binary search tree. So let's start. So first of all, we'll read the problem. Given the root of a binary search tree and the lowest and the highest boundaries as low and high, trim the tree so that all its elements lie in low and high range. Trimming the tree should not change the relative structure of the elements that will remain in the tree. That is, the node's descendants should remain a descendant. It can be proven that there is a unique answer. Return the root of the trimmed binary search tree. Note that the root may change depending upon the given bounds. So the basically in the problem, we need to trim the nodes of the binary search tree such that all its nodes lie in the range low to high. All the nodes which are less than low and which are greater than high should not come in the tree. So the problem is regarding this only. All the nodes should lie in the range of low and high, and in doing so, we need to preserve the relative structure of the nodes. So let's see the example. So the example of the problem is, so in this problem, low is equals to 1 and high is equals to 3. So we have 0, 1, 2, 3, 4. So we know that 0 is less than 1 and 4 is greater than 3. So we only need to have 1, 2 and 3. So we need to remove 0 and also we need to remove 4. So when we remove 0, so we have 2 and 1, and we need to also preserve the relative order. So that's why the left child of 3 becomes 2, and the relative order has been preserved. So that's how, like, the problem is the solution of the problem is going to be made. Okay, so for this we need to keep two things in mind. So what is the two things? So first of all, remember the property of binary search tree. So the binary search tree says that all the nodes which are on the left side of the root are less than the root, and all the nodes which are on the right side of the root are greater than the root. Okay, so keeping this property in mind, so we have two cases. So consider a case when we have the root value which is less than L. L means the low value. The low, it is less than low. So we know that the left of the root will always be less than the root value. So it means that we need to not we need not consider the left side of the root, but if we consider the right side of the root, so it might be bigger than the low value. So considering that we have got root value less than low value, we can neglect the left child of the root, but we cannot neglect the right child of the root. So for the first condition says that if the root value is less than low, then we need to see the root value, left right child of the root value. Okay, and the similar condition is in the second, when we have the root value and we see that the root value is greater than high. So it means that all the child that are on the right hand side of this root will always be greater than the particular h value. So we need not consider the right child of the root. So right child of the root can be neglected, but the left child of the root cannot be neglected, because in the left the values will be less than the root value, and it may happen that it may become less than h, that is the high value. Okay, so based upon these two conditions our solution will be made. So let's see the solution in the coding phase and then we'll explain. Okay guys, so we have the problem here. Let's start coding. So what we'll do, we'll make a new function named song and we'll make a recursive solution. I'll make low and int high. Okay. So if first of all we're terminating condition for the recursion is if the root is null, we need to return null. Now, if we have root val is less than L, so it means that this particular root value is not of use for us. So we need not consider the left child of the root, we only need to consider the right child of the root. So we only need to return root right child and comma h. So, and the another condition is if root's value is greater than h, so we need to return the left child of the root, and we can neglect the right child of the root, because if the root value is greater than h, then the right child value will always be greater than h also, and we don't want the values greater than h in our tree. And if the not any case is there, so we need to return the root value, and also we need to solve. So root left is equals to solve root left, because we need to go deep down and check whether that particular case is available or not. So for that we'll be adding these conditions. Okay, so return the solution. So okay, let's run the code. It's accepted. Let's submit. Yeah, so it's working fine. So it has been accepted. So the time complexity of this solution is big of n, because it will travel all the nodes once and then it will give the answer. So that's why the time complexity of this solution is big of n. And guys, if you like the video, press the like button, share the video and subscribe the channel. Thank you guys, thanks for watching the video.